Expected monetary value, EMV, is a technique used to quantify the potential monetary outcome of a risk event by multiplying its probability of occurrence by its potential monetary impact. This technique enables project managers and teams to evaluate and prioritize risks in monetary terms and calculate the amount of cost contingency reserve needed for the project. Following is the formula used to calculate the expected monetary value of a risk event. Expected monetary value equals the probability of a risk event multiplied by the monetary impact of that risk event. To illustrate, consider a construction project with three major risks as follows. Risk A, delay in material delivery has a probability of 40% and an impact of $50,000. Risk B, early completion of a project phase has probability of 25% and an impact of $20,000. And Risk C, weather-related delays have probability of 30% and an impact of $30,000. In this example, note that Risk A and C are negative risks, threats, while Risk B is a positive risk, opportunity. With these values, we can calculate the EMV for each risk as follows. EMV of Risk A equals 0.4 times negative $50,000, which equals negative $20,000. EMV of Risk B equals 0.25 times $20,000, which equals $5,000. EMV of Risk C equals 0.3 times negative $30,000, which equals negative $9,000. Since risks A and C are negative risks, their EMV is expressed as negative numbers. The EMV of Risk B, a positive risk, is expressed as a positive number. Based on these values, we see that Risk A has the highest priority, as it has the potential to make the greatest negative impact on the project. To address these risks, let's determine the appropriate cost contingency reserve that needs to be allocated to the project budget. To do so, we need to calculate their total expected monetary value. Total expected monetary value equals EMV of Risk A plus EMV of Risk B plus EMV of Risk C, which equals negative $24,000. This result indicates that the project team needs to allocate $24,000 in contingency reserves to account for the potential negative impacts of these three risks. Note that when calculating the amount of cost contingency reserve needed, negative risks increase the needed contingency reserve, while opportunities decrease it. The same principle applies for calculating schedule contingency reserves. In this case, however, we calculate the expected value of the schedule impact instead of the expected monetary value. Both expected monetary value and expected value are used to quantify potential risk outcomes, but they differ in their units of measurement. Expected monetary value calculates the financial impact of a risk, while expected value quantifies the potential outcome of a non-monetary impact, such as schedule delays. The following formula, based on the same principle as the expected monetary value formula, is used to calculate the expected value of a risk event. Expected value equals the probability of a risk event multiplied by the impact of that risk event. To illustrate, if we say that risk X has a 40% probability of causing a 10-day schedule delay, the expected value for risk X can be calculated as follows. 0.4 times negative 10 days equals negative 4 days. Lastly, let's take a look at the ultimate tips for exam success. You may need to calculate contingency reserves and prioritize risks based on their expected monetary values, so know the formula. For example, consider a question asking how much cost contingency reserve might be appropriate to cover the potential negative impact of an identified risk with a 10% probability and a $50,000 impact. In this case, the answer would be negative $5,000. When calculating the total contingency reserve for a project using the expected monetary value technique, negative risks, threats, are represented by negative numbers, which subsequently increase the contingency reserve required for the project. Conversely, positive risks, opportunities, are expressed as positive numbers, reducing the total contingency reserve. Both expected monetary value and expected value are used to quantify potential risk outcomes, but they differ in their units of measurement. Expected monetary value calculates the financial impact of a risk, while expected value quantifies the potential outcome of a non-monetary impact, such as schedule delays.